Preparing for a data scientist interview, questions and answers interview. You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like and share, and drop a topic request in the comments. Question 1. What does a data scientist actually do in a business setting? Data science turns messy business data into decisions using statistics, programming, and domain judgment. In practice, I start by clarifying the problem and success metric, then explore data quality, build baselines, test stronger models, and communicate trade-offs. A good data scientist does not just maximize accuracy, they ask whether the result changes a product, reduces risk, or improves customer experience in a measurable way first. While answering, focus on problem framing, data exploration, modeling, experimentation, business impact, stakeholder communication, and how data science differs from pure analytics or software engineering. Question 2. How would you approach a new data science problem from scratch? I begin by translating the business question into a measurable objective. For example, instead of saying reduce churn, I define the prediction window, target label, intervention strategy, and success metric. Then I inspect data sources, check quality, run EDA, and build a simple baseline. Only after that do I try complex models. I validate carefully, explain results to stakeholders, and decide whether the model is useful enough to deploy. Make sure to cover requirement clarification, metric definition, data availability, exploratory analysis, baseline modeling, validation strategy, iteration, deployment considerations, and how you align technical work with business goals. Question 3. What is the difference between supervised, unsupervised, and reinforcement learning? Supervised learning uses labeled examples, like predicting house prices from historical sales. Unsupervised learning finds structure without labels, such as customer segments using clustering or compression using PCA. Reinforcement learning is different. An agent learns actions through rewards, like a recommendation system optimizing long-term engagement. Most business data science uses supervised learning because labels and metrics are clearer, while unsupervised methods are valuable for exploration and feature discovery. In your answer, talk about labeled data, target variables, clustering or dimensionality reduction, reward-based learning, example algorithms, and practical use cases for each learning paradigm. Question 4. How do you handle missing values in a dataset? I first ask why values are missing. If data is missing completely at random, deletion may be acceptable for small amounts. More often, I use imputation, median for skewed numeric values, mode or unknown for categories, or model-based methods when justified. I also add missingness indicators if absence itself is predictive. The key is fitting imputation only on training data to avoid leakage, and validating the impact empirically. Be sure to mention missingness mechanisms, deletion versus imputation, numerical and categorical strategies, leakage risks, model sensitivity, missing indicators, and validating whether the chosen approach improves performance. Question 5. What is overfitting, and how do you detect and prevent it? Overfitting happens when a model learns noise instead of the underlying pattern. I detect it when training performance is strong, but validation or test performance drops. To prevent it, I use cross-validation, regularization, pruning for trees, early stopping for boosting or neural networks, and simpler feature sets. I also compare against a baseline. The goal is not the best training score, it is reliable generalization on future data. While answering, cover train-test performance gap, model complexity, noise memorization, cross-validation, regularization, pruning, early stopping, simpler baselines, more data, and feature selection. Question 6. Explain bias-variance trade-off with an example. Bias is error from overly simple assumptions. Variance is error from being too sensitive to training data. A linear model on a complex nonlinear problem may have high bias and underfit. A deep decision tree may have low bias but high variance, changing drastically with small data changes. Regularization, pruning, and more data reduce variance. Ensembles like random forests reduce variance by averaging many noisy models. Make sure to cover underfitting, overfitting, model complexity, error decomposition intuition, examples like linear regression versus decision trees, and how regularization or ensembling changes the balance. Question 7. How would you evaluate a classification model when classes are imbalanced? With imbalanced classes, accuracy can be useless. If only 1% of users churn, predicting no churn gives 99% accuracy, but zero business value. I look at precision, recall, F1, and especially PRAUC when positives are rare. Then I choose a threshold based on business cost. Missing fraud may be worse than reviewing false alarms. I also check calibration so predicted probabilities can support operational decisions. In your answer, discuss why accuracy can mislead. Precision, recall, F1 score, ROC AUC, PRAUC, confusion matrix, threshold tuning, business cost, sampling, and calibration. Question 8. What is data leakage, and can you give an example? Data leakage means the model gets information during training that would not be available at prediction time. For example, predicting loan default using a feature like collections contacted leaks post-default behavior. Another common mistake is scaling or imputing using the full dataset before splitting. Leakage produces excellent validation metrics and terrible production results. I prevent it by designing splits carefully, respecting time order, and verifying every feature's availability. Be sure to mention future information, target contamination, train test contamination, pre-processing mistakes, time-based splits, feature availability at prediction time, and why leakage creates unrealistic offline performance. Question 9. How do you choose between logistic regression and a tree-based model? I choose logistic regression when I need a strong interpretable baseline, calibrated probabilities, and roughly linear relationships. It works well with sparse features and is easy to explain. Tree-based models are better when relationships are nonlinear, interactions matter, or monotonic transformations are not obvious. Random forests reduce variance, while gradient boosting often wins tabular prediction tasks. I usually benchmark both and let validation performance plus interpretability requirements decide. While answering, compare interpretability, linear decision boundaries, feature scaling, nonlinear interactions, categorical handling, robustness, dataset size, calibration, and when gradient boosting or random forests are preferred. Question 10. What is regularization and why is it useful? Regularization discourages overly complex models by adding a penalty to the loss function. L2 regularization shrinks coefficients smoothly and helps when many features contribute small signals. L1 can push some coefficients to zero, acting like feature selection. In practice, regularization reduces overfitting and improves generalization, especially when features are correlated or data is limited. The penalty strength is a hyperparameter, so I tune it using validation or cross-validation. Make sure to cover penalizing complexity, L1 versus L2, coefficient shrinkage, feature selection, overfitting reduction, hyperparameter tuning, and how regularization affects generalization. Question 11. How would you design an A/B test for a new product feature? I start with a clear hypothesis, like the new onboarding flow increases activation rate. Then I define the primary metric, guardrails such as retention or latency, randomization unit, and target population. Before launching, I estimate sample size using baseline rate, minimum detectable effect, power, and significance level. During analysis, I avoid peaking, check balance, and report confidence intervals. A statistically significant result still needs practical business impact. In your answer, include hypothesis, primary metric, guardrail metrics, randomization unit, sample size, experiment duration, statistical significance, practical significance, and avoiding peaking or selection bias. Question 12. What is the difference between correlation and causation? Correlation means two variables move together. Causation means one variable directly changes the other. Ice cream sales and drowning incidents may correlate because both rise in summer, not because ice cream causes drowning. Randomized experiments are the cleanest way to establish causality because they balance confounders. In observational data, I use methods like matching, regression controls, difference in differences, or instrumental variables, but I communicate assumptions clearly. Be sure to discuss association versus causal effect, confounding variables, randomized experiments, Observational studies, causal inference methods, and why business decisions require more than correlation. Question 13. Explain p-value and confidence interval in simple terms. A p-value tells me how surprising the observed result is if the null hypothesis were true. It is not the probability that the null is true. A confidence interval gives a range of plausible effect sizes, which is often more useful. For example, a conversion lift of 0.2% to 0.4% is more actionable than just p less than 0.05. I always pair significance with effect size and business relevance. While answering, cover null hypothesis, probability of observing data under the null, common misinterpretations, uncertainty estimation, confidence interval meaning, and practical versus statistical significance. Question 14. How do you detect and handle outliers? I first determine whether an outlier is an error, a rare but valid event, or the actual signal I care about. I use box plots, histograms, z-scores, IQR rules, and domain checks. If values are data errors, I fix or remove them. If valid but extreme, I may cap, transform, or use robust models. The wrong move is blindly deleting outliers, especially in fraud or risk problems. Make sure to mention domain validation, visualization, z-score, IQR, robust statistics, capping, transformation, model choice, anomaly versus error distinction, and documenting the decision. Question 15. What SQL concepts should a data scientist be strong in? A data scientist should be very comfortable with joins, group by, filtering, date logic, CTEs, and window functions. Many interview problems involve finding retention, ranking users, calculating rolling averages, or detecting duplicates. I also care about correctness, understanding grain, avoiding double counting, and checking null behavior. Performance matters too, so I avoid unnecessary cross-joins and filter early when possible. SQL is often where analysis quality begins. In your answer, talk about joins, aggregations, window functions, CTEs, subqueries, filtering, date handling, query performance, data validation, and translating product questions into reliable queries. Question 16. How would you build features for a machine learning model? Feature engineering starts from the behavior I want the model to capture. For churn, I might create recency, frequency, tenure, support tickets, plan changes, and engagement trends over fixed historical windows. I encode categoricals carefully, transform skewed numeric variables, and add interaction features when meaningful. The biggest rule is avoiding leakage. Every feature must be available before prediction time. I keep features only if validation shows they improve performance or interpretability. Be sure to cover domain knowledge, aggregation windows, categorical encoding, numerical transformations, text or time features, leakage prevention, feature importance, and iterative validation against a baseline. Question 17. What is cross-validation? And when would you avoid random k-fold cross-validation? Cross-validation estimates model performance by training and validating across multiple data splits. In k-fold cross-validation, each fold becomes validation once, giving a more stable estimate than a single split. I avoid random k-fold when data has time dependence, user-level grouping, or leakage risk. For time series, I use forward chaining splits. For user data, I split by user, not event, so the same person does not appear in both train and validation. While answering, discuss model evaluation stability, k-fold process, stratification, time series splits, grouped data, leakage risk, small datasets, and when train validation test splits are more appropriate. Question 18. How do you explain a machine learning model to non-technical stakeholders? I explain the model in terms of the decision it supports, not the algorithm first. For example, this model ranks customers by churn risk, so the retention team can prioritize outreach. Then I show performance using business metrics, key drivers, example predictions, and limitations. I avoid jargon like regularization unless needed. Stakeholders need to know when to trust the model, when not to, and what action follows from its output. Make sure to cover business framing, simple language, key drivers, limitations, examples, uncertainty, metrics that matter, visual explanations, and avoiding jargon while preserving accuracy. Question 19. How would you monitor a model after deployment? After deployment, I monitor both system health and model health. System metrics include latency, failures, and throughput. Model metrics include prediction distribution, feature drift, missing values, calibration, and business outcomes once labels arrive. I compare live performance against offline validation and set alerts for major shifts. If the target relationship changes, that is concept drift and may require retraining, new features, or even redefining the problem. In your answer, include data drift, concept drift, prediction distribution, performance metrics, latency, calibration, feedback loops, alerting, retraining triggers, and comparing online results with offline validation. Question 20. Tell me about a time your analysis changed a business decision. I would answer this with a star structure. For example, I analyzed why trial users were not converting to paid plans. After segmenting by acquisition channel and product usage, I found that users who completed 2 key actions in the first week converted 3 times better. I recommended changing onboarding to drive those actions. The decision shifted from discounting to activation, and I would quantify the final impact with conversion lift and revenue. Be sure to structure the answer with context, problem, data used, methodology, insight, recommendation, measurable impact, stakeholder communication, and what you would improve next time. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.